Hey guys, let's take a look at graphing quadratic functions. We're going to graph f of x equals x squared plus 4x plus 3. And the very first thing that we're going to calculate is the axis of symmetry. But before we do that, we need to make sure that we see that our a is 1, our b is 4, our c is 3. Axis of symmetry is the tiniest little formula. It's just negative b over 2a. And if I plug my values of b and a into this function, and then I end up simplifying it, I end up getting negative 4 over 2, which is negative 2. Negative 2 is going to be the vertical line that cuts my parabola in half right down the middle. And it's also the x value of my vertex. So if I go ahead and I plug in a negative 2 everywhere I see an x, and I go ahead and evaluate this, negative 2 squared is 4. 4 times negative 2 is negative 8, plus 3. 4 minus 8 is negative 4, plus 3 is negative 1. My vertex is negative 2, negative 1. We're going to make a table here, and so I'm going to draw a table, and anytime we draw a table, you can have as many values in it as you want. I like to make 5, and I like to always put my vertex in the center of my table, so negative 2, negative 1. I also just have my x values increase by 1s, and then what I'm going to do with my y's is I can either plug in all of my extra x values into the function and do exactly what I just did here, or there's a special pattern. When the a value is 1, all you have to do is add 1, add 3. So from the vertex, you would do plus 1 is 0, and then plus 3, which is 3. And you have a beautiful symmetry with the table. The bottom numbers are the same, just in reverse order. So now I can go ahead and plot my points and make my beautiful parabola here. Excellent, excellent, looks awesome. The domain of every quadratic function is always going to be all reals. And then when I look at my range is about the y-axis. And so when I look at this graph, I see it starts on the y-axis at negative 1. The entire graph is above it, so y is greater than or equal to negative 1. Good job.